What chapter and what section was this on?
6.1, when we started talking about functions of multiple variables. So this is set builder notation.
So for this, like if you have a rational function.
Yes, I'm ready.
Say,
Yes.
square root of y over, let's say, x squared plus 1.
Let's make it even more interesting. Let's say x squared minus 1. We discussed this from the very beginning. I have to write y greater than or equal to 0. We discussed this from the very beginning. Cannot be plus or minus 1. So then the domain for this will be any ordered pair as long as these conditions are fulfilled. That's it. You don't have to write anything else. We discussed rational functions a lot. We discussed squared root a lot. That's the condition. Now, if the square root is in a denominator, then it's a different story. I cannot put the equal symbol to 0. So it's just a combination of what we've studied from the very beginning. And finally, you write it like this, because that's the only way we can present it for a function of two variables.
Thank you.
Thank you.
Can I do an approximation question?
Absolutely. So you want the integral of something, dx, and you want to use an approximation because we cannot find the antiderivative. Is that?
No, I was thinking more of the delta y.
Oh, very good. Okay, so let's say we are looking at the square root of 102. And we want to approximate it. And we know the formula. This is f of a plus f prime of a. I shouldn't write it like this, but because if I started with a different formula, so this is x minus a. But better the one that we discussed in class. This is correct. So the square root of 102 is approximately f of x plus f prime of x dx. They are the same. This is this, this is this, this is this. Okay, so here I have to find f of x, I have to find x, and I have to find dx. And of course I also have to find f prime of x. When you look at nothing else but this, what function do you see? What function do we see here?
The square root of that.
That's it, absolutely. And I know you're going to say f prime of x is 1 over this 2 the square root of x. Now we have to identify x, and we have to identify dx. This has to be small, and this can be anything, but this has to be small. Don't say 99 or 101 or something like that. It has to be small. So now look at 102. Look at the fact that this is a square root, and give us your best shot to x and a tiny error in x, or a tiny difference.
100.
Of course, absolutely, because it's the square root of 100, right? And the tiny x is dx. I found everything. I only have to fill this in. That's it. What is f of x? It's the square root of 100, which is 10. Plus, what is f prime of x? 1 over the square root of 100, which is 10. 2 times 10, 1 over 20. Times dx, which is 2. And I'm done. I'll simplify, and I get 101 over 10. That's the final answer. The square root of 102 is very close, not equal, very close to 101 divided by 10. And you should always check with the graphing calculator. It's always smart to do that. Take the square root of 102 And when I plug in, of course I know what that is. It's 10.1. There is no need to do this, but let's say it could be anything. So 10.0995 is very close, not equal to, but very close to 10.1. So we approximated this using calculus.
Okay, thank you.
Thank you. Very good question. Good. Next question. Anything else you'd like to go back to? Anything? Other questions? Donna, are you still looking? It's okay if you're still looking, you don't have to.
Yeah, I'm just scrolling through the test.
Sure.
I was trying to think, I know on test 3 I can't think of the problem, but I know that there was one that I was stuck on, but I didn't, I can't remember what it was. I'm just scrolling through test 1 and 2 just to see if there's anything I have questions on.
Sure. And do you remember what the question was, even if it's vaguely on test 3?
Not remember. One of them was one that we just went over. It was the where we had the DY. So that was one that was number 2 on the test. I know I was struggling with that one because I couldn't remember either. So we went over that just now because Carmen asked for it. So we did
Okay.
that one.
Okay, awesome. I'm assuming you are taking your notes with you, right? When you go
Yes,
to...
I
Oh,
take my notes.
oh.
with me, and it's weird because I have so many of the notes, and I don't know. Sometimes when I get to the test, I don't know what happens. It's like and I ask a lot of questions in class, and I've been watching the videos. It just seems like I just can't seem to piece it all together. Like I can get bits and pieces of how to do some of the stuff, but sometimes putting it all together is just hard for me.
I completely understand. That's why I'm trying to do everything as slowly as possible, and I ask you to ask questions and participate because I know it's a lot. 15 weeks, a lot of material. I know that. Good. Next question. Let's use the time efficiently. I never want to waste your time.
Can I ask you just real quick for the now linear regression on the calculator?
Yes. I have a video that I posted.
Right.
Okay.
I just feel like I do it wrong every single time. I don't know. So it's really just going into the stat and edit, putting in your list 1, your list 2,
Right.
and then going into Zoom to choose the Zoom stat option.
Because I'm not asking you to graph it, but you should see it, right? So once you go to, do you have any data set that you want me to add in?
Sure.
If not, I can make something up.
No, I have something in here already. Let's see. Second. Wait. I have the list 1, 2, 10,
Okay.
16,
2, 10, 16.
20, 21, 34. And then for list 2, I have -3, 18, 28, 38, 45 and 63.
Double check because I think I missed something, or was it slow?
Nope, you got it.
Okay, so now we go to stats. So see, I prefer, but that's my preference. I prefer to look, okay, so 2 is the smallest, 34 is the biggest, -3 and 63. And I can adjust my viewing window myself. Fine. But you have the option of going to Zoom and using the Zoom stats. I don't prefer that because it doesn't tell me the scale, yada, yada, yada. And it may not even do anything. Hold on one second, because I have something in here. And I have to go to second and turn on a plot. Okay, and now it's gonna work. So I go again to Zoom stats and I see it. I don't like it because I don't know what this is. Is it 1 by 1? What is it? I'm assuming it is. So it kind of looks linear, and now I go to second and quit, go to stats, and I want calculations, and I want number 4. And
Gotcha.
yeah, and I want the calculator to put the data in there, the linear
So you
regression. So I go
so
to
you
go ahead.
You hit bars and then you go
Yes.
to Y and
Yes.
function.
And I choose function, the first one. Yeah. You can choose the second one. It doesn't matter which function you choose. I cleared everything. So, yes. And then I calculate. And I know that A is the slope of the line. So it's positive. B is the y-intercept, -4.19. And now if I want to evaluate, I go to the table and I evaluate, and I should evaluate somewhere close to the range of x values. Let's say, I don't remember what we had, let's say 21. I think we had 21, didn't we? Let's say 18. I think we had 18. Let's say 17. And this is the predicted value, 31.15. For 17, will this be accurate? No. But it's a predicted value. That's all we
Okay.
want. So we want to say, okay, the shares of Apple tomorrow will be 31.15 approximately. Do we want to buy or want to sell? So it's an estimate. It's a predicted value through the linear regression line. And now when I graph again, I should also see the line. It's the line of best fit. In other words, it has the minimum error. And once we talk about minimum, we talk about calculus. And here we talk about the minimum error. That's why this setup or this topic is here in calculus.
Okay, so once you go in from stat and add in your y1 to get the equation in slope-intercept form, if you're asked like evaluate when x is 18,
You just-
plug in 18 for x.
Yes, you go second in table, and you plug in whatever you're asked to plug in.
Second in table, okay.
Can you do this by hand? Yes, but if you don't do it by hand, or you do it, in other words, with a calculator, it will take you 3 minutes. If you do it by hand, it may take you 10.
Okay, thank you.
Thank you.
I did it right then.
Awesome, excellent. Good, very good. Next question, please. Anything else? Other questions from any test, any topic? gonna go to the book. Is there anything else that you have ready?
If no one's gonna ask anything else, I'm gonna keep asking questions.
You are my lifesaver. Ready?
Can we do above minus below? What do you call that?
Yes. So, for example, if we have, if we're asked to determine the area between these two functions,
Yes, the areas among two
right.
curves.
So we have this function above minus below. So here's again why this is the case. Because if I want to determine this area, I will determine this area under the function that is above, and I will subtract the area under the function that is below to get this one.
Yeah, the concept is very easy to understand. It's just the calculus that can get a little bit confusing.
The calculus is very easy. The algebra is difficult because we have to graph, we have to find the point of intersection, yada yada. Again, the algebra is the culprit here. Yes, I'm ready.
Right.
Yes.
You're
The calculus is the integral from a to b from f of x minus g of x.
And A to B are the intersection points.
Exactly.
of the two graphs.
That's it.
Okay, so then what is confusing for me on test 3 was just feeling like I graphed it correctly.
Okay.
I found the intersection points. I put the function that was above minus the function that's below, and then I was trying to do all the math, and it just kept looking wrong after that.
And remember, it has to be positive. If it's enclosed between two graphs, it will always be positive. Good. So let's take a look at any example that you have for us. Any?
How about y equals x and y equals x squared minus 2?
Excellent. So remember what I like to do? I like to find the points of intersection first, so I don't have to adjust the graphs later. So when I set them equal to each other, x equals x squared minus 2, or x squared minus x minus 2 equals 0. You can use the feature in the calculator, the apps, but this is too easy to factor. So I have x equals -1 and x equals 2. So somewhere here at -1 and somewhere here at 2, the functions have to cross. So when I plug in -1 here, it's -1, -1. So this is 1 point for sure. When I plug in 2, 2, 2. So that's another point for sure where they intersect. So now I will graph y equals x, which is super easy. It's this line that bisects first and third quadrants. So this is y equals x. Now this one is also super easy. Why is it super easy? Because it's x squared minus 2. So we will cross here, and it has to go through those 2 points. And that's all I need. So
Okay, that was easier than what I did. I found the vertex with f prime.
that's fine. That's fine too. But this is x squared. This is from algebra, right? X squared down 2.
Okay, perfect. So then it would be the integral from 2 to -1.
Careful. -1, 1 to 2.
-1 to 2.
From above,
X.
yes,
So x
minus
minus
below.
x squared minus 2x dx.
Remember, when I distribute, this becomes negative. When I distribute, this becomes positive. Perfect. So it's done. It's x squared over 2 minus x cubed over 3 plus 2x from -1 to 2. So we plug in 2 first, and then subtract when we plug in -1. So when I plug in 2 squared 2, 4 over 2 is 2. So this is minus 8/3, and this is plus 4. Minus, put parentheses so you don't make a mistake, 1/2 plus 1/3 and minus 2. 2 plus 4, 6, minus 8/3, minus 1/2, minus 1/3, and plus 2.
Okay, I got that far because I felt like I was doing it wrong, but now I know that I wasn't doing it.
No, so that's fine. So this is 8. Negative 8/3 minus 1 is negative 9/3, so this will be negative 3, and minus 1/2. So 5 minus 1/2 is 9/2. We can always check with the graphing calculator. You should. You don't want to lose points, right? So we go to math and we go to number 9, and we go to math, we go to number 9, and we have from negative 1 to 2, and of course the x, and the first function, so it was x minus x squared and plus 2. When I hit enter, I have to get that 4.5. If I don't get 4.5, something is terribly wrong, and I have to go back. So as expected, the area is positive. It's enclosed between two functions.